Welcome to this screencast where we will demonstrate the ability to perform Kubernetes inter-cluster workload transitions between two HPE Nimble Storage dHCI systems running Google Anthos. In this demo, we have two independent HPE Nimble Storage dHCI systems deployed in two separate data centers, A and B. Between the systems, we have asynchronous replication set up. We'll deploy our application with persistent storage in data center A. We also have an external load balancer that understands the topology. The client application is accessing the application through the external load balancer. We're going to use standard Kubernetes tooling to tear down the application in data center A and deploy it to data center B and have the data seamlessly transition to the new location. Let's get started. I have a 3-node Google Anthos cluster deployed in data center A. We'll leverage a standard Kubernetes storage class to perform the volume transitions, allow PVC annotations from users to present the volume. The key parameters here are sync on unmount and the protection template that in combination will automatically sync the last volume updates when the workload gets shut down. The initial creation of the application is fairly straightforward. We'll create the PVC, our application, which is a MariaDB, and an ingress for our external load balancer to communicate with the application. Let's wait for the application to come up. On the HPE Nimble Storage array in data center A, we now have a volume. Switching to the array in data center B, we can observe the replica of that volume. I'm going to deploy my client application, which is simply a Python script that inserts and selects data using our deployed database. dping is an open source application available on GitHub. The app inserts a row, disconnects, and then selects the last row inserted. We need to acquire the name of the volume being backed by the application. This volume will be imported on data center B with another set of flags that will take over the ownership of the volume and reverse the replication to data center A. First, we need to delete the application from data center A. Then we need to connect to the cluster on the remote site. It's running a 3-node cluster using Google Anthos. As expected, we can also see our client application has paused. Let's redeploy our application in data center B. The client application resumed where it left off, with up to the last transaction integrity. Refreshing the HPE Nimble Storage Array UI in the data center A, we can observe that the volume is now an offline replica. Switching to the HPE Nimble Storage Array in data center B, the volume is online and serving the application. Imagine that we wrapped up some maintenance we performed in data center A. So we're going to transition the application back to its origin. We need a new volume name to transition back as it gets assigned a new UID each time it's being created. Delete the application. Connect to data center A. Recreate the workload, ensuring the right objects are getting created. The application is up and running already, and the client started responding with up to the last transaction integrity. The HPE Nimble Storage Array in data center A is now back to serving the data, and data center B is now offline, receiving the updates from data center A. This concludes the demonstration on how to perform inter-cluster seamless workload transitions with Google Anthos deployed on HPE Nimble Storage dHCI. Take care and see you next time.